Let's talk about chemical formulas and chemical equations so that you're well prepared as we move on in this unit. So let's start with the chemical formulas. Chemical formulas tell us the types of atoms and how many of those atoms make up a molecule. Let's look at a molecule that you're already familiar with, oxygen. O2 is the chemical formula for the oxygen molecule, and it tells us that 2 oxygen atoms make up one molecule of the oxygen that we breathe. Let's talk our way through a more complicated molecule, sulfuric acid. The chemical formula for sulfuric acid is H2SO4. This means that in one molecule of sulfuric acid, there are 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. How do we know this? We know this because of the subscripts. Those little numbers that are written just after the letters that represent the atom. So we know we have 2 hydrogen because this 2 tells us 2 hydrogen. We know we have 1 sulfur because there's no number here. If it was 0, we wouldn't have an atom there. So if it's 1, we don't put any number there. So the atom being present and no number after it means that there's 1 atom. And then the 4 tells us that there's 4 oxygen atoms. What if we have 2 molecules of sulfuric acid, or 2 H2SO4? We now have a number at the start of the formula, and this number tells us how many molecules there are. In this case, 2 molecules of the sulfuric acid. It's important to distribute this number to each of the atoms in the formula. So in this case, we have 2 H2s. So see, we have H2, but we have 2 of them. We have 2 S's, and we have 2 O4s. So what does that mean for the number of atoms? The 2 H2s gives us a total of 4 hydrogen atoms. The 2 at the beginning times the 2 subscript, so that means 4. There are 2 S's. That means a total of 2 sulfur atoms. The 2 at the beginning times the 1 subscript. 2 times 1 equals 2. And lastly, there are 2 O4s. So that means a total of 8 oxygens. We take the 2 from the beginning of the molecule, because there's 2 molecules, and then we multiply that by 4, the subscript on the oxygen. And 2 times 4 is 8. Now it's your turn to practice. When you answered that question, you had to think about the subscripts. There was no subscript on the C, so that means 1 atom. And there was a 4 subscript on the H, right here. So that means 4 atoms. In one molecule of methane, or CH4, there is 1 carbon atom and 4 hydrogen atoms. This is what one molecule of methane looks like, and you can actually count the atoms. So here we see the 1 carbon, 1 carbon. 4 hydrogens, 1, 2, 3, 4 hydrogens. Let's try another one. Once again, when you answered that question, you had to think about the subscripts. There was a 2 subscript on the H, so that means 2 hydrogen atoms. There was also a 2 subscript on the oxygen, so that means 2 oxygen atoms. In one molecule of hydrogen peroxide, there are 2 hydrogen atoms and 2 oxygen atoms. This is what one molecule of hydrogen peroxide looks like. And again, you can count the hydrogens. The subscript tells us there are 2 hydrogen atoms. Here's 1, here's 2. And the subscript on the O tells us there are 2 oxygen atoms. There's 1, there's 2. Here's a harder one. This time when you answered the question, you had to think about the subscripts and the 3 that was at the beginning of the formula. The 3 has to be distributed to each atom in the molecule. The 3 tells us that there's 3 molecules of carbon tetrachloride. There was no subscript on the C, so that means 1 atom, but the 3 applies to the carbon at the beginning, so 3 times 1 equals 3, so that means 3 carbon atoms. There was a 4 subscript on the chlorine, so that means 4 atoms, plus you need to apply the 3. There is 3 times Cl4. 3 times 4 is 12, so that means 12 chlorine atoms. In 3 molecules of carbon tetrachloride, there are 3 carbon atoms and 12 chlorine atoms. This is what 3 molecules of carbon tetrachloride looks like. You can count the atoms. So we know we have 3 C. So here we see them 1, 2, 3, and 3 times 4 chlorines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now that we've got chemical formulas under control, let's take a look at chemical equations. Chemical equations are just statements that use symbols to show the changes that happen during a chemical reaction. Let's take a look at an example. Here's the equation for the breakdown of hydrogen peroxide. The equation uses chemical formulas and symbols. We can look at this and understand what it means, but you wouldn't say it out loud this way. That would be really difficult to follow. If I was to say to you, 2H2O2 arrow 2H2O plus sign O2, you'd be looking at me like, what? I couldn't follow that. Can you repeat that? So when we talk about chemical equations, we convert those symbols into words. So if we were to change this equation into a sentence, we would just substitute the words for the symbols. So based on what we know about chemical formulas, here's what we'd say. 2 molecules of hydrogen peroxide. The arrow means react to form. Here's H2O water, so 2 molecules of water. Plus sign means and O2 you recognize as oxygen. So if I asked you what this equation was, you would say to me, 2 molecules of hydrogen peroxide react to form 2 molecules of water and 1 molecule of oxygen. Let's try another one. By now you should recognize these molecules. And once again, we just change the symbols into words. 1 molecule of methane and 2 molecules of oxygen react to form 1 molecule of carbon dioxide and 2 molecules of water. There's one more part of chemical equations that we need to make sure we understand, and that's reactants and products. When you started this part of the unit, you were asked to brainstorm a list of things that go into organisms and are released from organisms, and we use the terms inputs and outputs. Inputs are just what's put in, or taken in, or operated on by an organism or a process. Outputs are what come out of or is produced by an organism or process. When we are talking about chemical reactions, we use very specific words to describe what goes in and what comes out of those reactions. And those terms are reactants and products. Reactants are substances that are initially present in a chemical reaction, and the products are substances that are formed as a result of the chemical reaction. And it's very easy to know which is which. Reactants react to form products. Remember, we learned that the arrow symbol means react to form. So just remember that the reactants are the starting material, so they're always found to the left of the arrow or before the arrow. And the products are what come out of the reaction, so they're always found to the right of the arrow or after the arrow. So if we take a look here, the methane and the 4-chlorine, they come before. These are the reactants, and they react to form, and they make the products, carbon tetrachloride and the 4-hydrochloric acid. Now you give it a try. In the questions you were asked, you just had to look at what was on the left side of the arrow to get the reactants, so the methane and the 2 oxygen. So here, to the left of the arrow. And what was on the right side of the arrow to get the products, the carbon dioxide and the 2 water molecules. Let's try one more. In these questions, you're once again asked to identify the reactants and the products. And again, you just had to look at what was on the left side of the arrow for the reactants. And in this case, there's only one reactant. And it can differ. Sometimes there's 1, sometimes there's 2, sometimes there's 3. There's no set number of reactants. So in this case, we have this one reactant, the 2 molecules of hydrogen peroxide. And then to get the products, we just have to look what's on the right side of the arrow. And the same is true for products. You might have 1, 2, 3. It differs for different chemical reactions. But in this case, to the right of the arrow are our products, so the 2 water molecules and the 1 oxygen molecule. Hopefully that went well, and you'll have no problem reading chemical formulas and chemical equations later in this unit. If you do need more help, do the interactive lecture. And you can always come back to these lessons at any time if you need a refresher.